is the effect of air? We have active earth pressure and passive, and how can I determine which side is passive, which side is active? If you have water table, what is the effect, and what is the difference between lateral pressure of water and lateral pressure of soil? K active can be calculated using phi, angle of internal friction, 1 minus sine divided by 1 plus sine. K passive, the inverse for this function. Sometimes you have surcharge, additional load on the ground surface, so we need to consider this in the lateral pressure. The best scenario, at any point in the soil, your vertical pressure first equal gamma soil H. Everything above, if you have surface load here, go ahead and add Q. If you have anything else, go ahead and add it. If you are looking for what is the lateral pressure at this point, your lateral pressure equal your vertical pressure times K. And this K may be K active or K passive based on which side you are looking for. If you have soil and you have water table like this, so what should I do? Do you remember?
Break it up.
This one can be done by, we have water pressure alone, plus we have soil pressure alone. But remember, for soil pressure, this part, I'm going to use gamma soil. But this part, I'm going to use what?
Gamma water.
No. No, I have water plus soil. I'm talking about the part of soil. The above part, the regular gamma soil. But for this part, I'm going to use effective unit weight. Your effective unit weight equal gamma saturation minus gamma water. So we have pressure from water. We have pressure from soil. Something looks like this. Then you need to add them together like this one. Okay, so in this case, we have soil. This soil is the same like this one, but the difference between this part and this part, this one is saturated with water, but this one not saturated. Maybe we have a little bit of water content. So any point in this part, I'm going to use gamma, regular gamma. But any point inside this part, I'm going to use gamma effective, which equal gamma saturation minus gamma water. And then we have another effect of the water pressure. Last time, we talked about stability of retaining wall. We have two types of stability. Overturning stability, if you are looking to calculate the factor of safety against overturning, your factor of safety equal resisting moment divided by overturning moment. If you remember our example last time, we have lateral pressure force, we have vertical weight of this part of soil, we have vertical weight of the retaining wall, we have vertical weight for this part of soil, we have lateral passive pressure. We are looking for overturning about this specific point, which is called toe of the retaining wall. You have to decide which force will cause resisting moment and which force will cause overturning moment. All the time, or most of the time, 99%, this active lateral force will cause overturning moment only. And all of other forces will make resisting moment. You can see, if you take moment at this point, this is the only force would like to rotate your retaining wall in this direction. Any other force will resist this overturn. We are looking for factor of safety something between 1.5 and 2. For any way, any situation, any case, your factor of safety must be greater than 1 to be safe. To take factor of safety, we need this number to be something between 1.5 and 2. The second, stability check sliding against sliding. Maybe your retaining wall will not overturn, but will move as one unit. So we need to check against sliding. If you are talking about sliding, so we are looking for lateral force. What is the active lateral force? What is the passive lateral force? And we have friction here. Do you remember your friction force equal mu times n? And the normal force on this surface equal everything coming from up. Everything. We have weight of the retaining wall. We have weight of soil. We have weight of soil. Maybe we have surcharge here. So everything coming from up vertically equal your n. Multiply n by mu, you can figure out what is the friction force. To figure out what is the factor of safety against the sliding, you need to divide summation forces, summation of resisting force. Which force is cause resistance? I think this one, your friction force resisting sliding. And the only force for sliding, which cause sliding, is the active force. Divide this force by this force, you can figure out what is the factor of safety. Any questions so far?
It's almost like a statics and dynamics question.
Yeah, yeah. Actually, we are taking just a few information or general information about retaining wall, but retaining wall as a retaining wall should be designed in foundation course. You know, it's not in complete course. I would like to define the different name or the different component of the retaining wall. We have this part called arm or stem of the retaining wall. This part, the whole part, called footing of the retaining wall. This point of the footing called toe. This point of the footing called heel. And sometimes we can add this part below the footing, which called key. Anybody here know what is the main purpose of the key? What's the main purpose? If your slide check is unsafe, this one can help you to increase the resistance for sliding. Because your passive pressure will be bigger. So this key to increase resistance against sliding. Sometimes you have this part, sometimes not. So we have different component on the retaining wall: stem, toe at the front of the wall, heel at the back file, side, and shear key. One more thing. If you would like to expect or to assume the dimension of the retaining wall at the beginning, then go ahead and make a check. We can assume the dimension based on these assumptions. Everything will be defined related to the total h, the total height of the soil, or the retaining wall. So if the total height is h, I can assume the total length of the footing something between 0.5 to 0.7 h. I can assume thickness of this footing something around 0.1 h. I can assume this thickness of the stem, if this one is sloped like this, we have change or variable thickness, I can assume this one at the base 0.1 h, and this one the minimum distance here or minimum thickness something around 12 inch or 0.3 meter. This is the minimum. Yeah, this part of the footing can be assumed 0.1 h, so I can figure out your dimension, like this example. We have retaining wall. The total height of this retaining wall equal 21 feet. The total height equal 21 feet. Estimate sizes of the component of the retaining wall, and please add one more part and check stability. Your problem in the exam will look like this. I will give you a retaining wall without dimension. So please go ahead and assume your dimension. Once you did your dimension, go ahead and make check of stability against overturning and against sliding. Something is missed here. We have soil on the other side with depth equal 6 feet. Your edge, total height, 21 feet. So what do you think? How much for this length? How much for this length? How much for this thickness? Looks like your thickness is constant, but anyway, this term, something around 0.5 to 0.7 h. Your h is 21 feet, so what do you think? We can assume 8.5, so it will be 10.5 feet. What about this thickness? 0.1 h. So I think we can assume it something around 2 feet. Not exactly 2.1, but you can start with 2 feet. And I will assume this one 0.1 h. Wow, 0.1 h, so that means I have to assume this one 2 feet. And this one is 1 feet is given, so your thickness should be variable like this. What about this term? How much? Is it 0.1?
Yeah.
0.1, so 2 feet also. So the final shape of the retaining wall, something like this.
So are we assuming that the stem is at an angle? So that's why we use the.
Yeah, like this. Because 1 feet thickness is given at the top. And this thickness should be something around 0.1 h. So 0.1 h equal 2 feet. So this one is given 1 feet. This one is estimated to 2 feet. That means I have variable thickness. charge given. How much? 300 pound per square feet.
Dr. Emin, where does that angle come from?
Which angle?
The 30 degrees?
Phi, the interlock or the friction between particles of the soil. This phi is important to figure out what is the K active value, 1 minus sine phi divided by 1 plus sine phi. If you have sand, between the particle of the sand, we have friction in between. This friction can construct a relationship. Based on this relationship, I can figure out what is the value of phi.
And that would come from like a geo report or something?
Yes.
Yeah.
Yeah. Soil mechanics. So this dimension 6 feet. This dimension total 10.5. You can assume it 10. That's fine. Not exactly 0.5 to 0.6, but something around. So it's okay. Let's start 10 feet, and this distance 2 feet. The thickness 2 feet. This one 2 feet, and this one is given 1 feet. So first term, I estimated the size of the component of the retaining wall. Second part of the problem, go ahead and check stability. What we did last time. Check stability. We don't have water table, only one type of soil with gamma equal 100. So we have here active earth pressure. Anybody can tell me how much pressure here? No, not 0.
300.
Not 0, not 300. At this point, which is at ground surface, we have surcharge. And this point. Okay, for soil, what is the value of vertical pressure? What is the value of vertical pressure? 300. What is the value of vertical pressure at this point? Everything coming from up. 300 plus gamma h. 300 plus gamma equal 1